Again, it's a rich thing.
What is going on, guys? Welcome back. In today's video, we're going to build a fully functioning TCP chat app in Python. And this is what it's going to look like in the end. This is going to be the Android app. And since it's written in Kivy, we're also going to be able to run it on the computer. This is what it looks like on the desktop. And all of this is going to connect to a server which is hosted on the internet. So it's not locally, it's hosted on the internet. We can connect with the phone, we can connect with a laptop, we can connect with the phone from somewhere else to the same server, and we're going to chat. And I'm going to demonstrate to you how this works. I'm now connected to the server via SSH, so I can run the server. You can see server is running. And now what I do is, first of all, I'm going to connect with the computer so that you see what I'm doing. I need to first enter the IP address. That's the IP address, so I'm going to copy it. And I'm going to paste it here. Then I'm going to choose a nickname. I'm going to call myself Neural, connect. And there you see Neural joined the chat, connected to the server. Now I'm going to do the same thing on my phone now. I just need to look at the IP address again. So it's going to be 31.170.165.142. And I'm going to pick the nickname 9. And now I'm going to connect. There you go. You can see in the background here, 9 joined the chat. And now I can chat from my phone. I can write, hey, what's up? And I can send that message to the chat. And you can see on my computer, I also get that message. I can write back, not much. How about you? Question mark. Then send this. And even though you're probably not going to see this by me holding it in the camera, maybe I'm going to add some screen recording of the phone. I also get these messages on the app. So this is what we're going to build today. We're going to build a TCP chat server, which is going to be running on the internet, and we're going to build a respective desktop and Android application as well. So let us get right into it. Now, before we get into the actual tutorial, I would like to mention that this video is sponsored by Hostinger. And don't skip that part, because this part is going to be relevant to the video. We're not just going to talk about the sponsor and then forget about it. We're going to use Hostinger for today's video, because what we want to do is we want to run the server on the internet. Now, of course, if you want to, you can also run it locally on your laptop, on your Raspberry Pi at home, in your local area network. But if you want the script to be ran on the internet, you gotta have a dedicated server for that. You need to have some hosting provider that provides you with a dedicated server, and Hostinger can do that for you, and they're sponsoring that video. They have provided me with the VPS 2 hosting plan for this video today. This is what we're going to use here. We have 2 cores, we have 2 gigabytes of RAM, we have 40 gigabytes of SSD storage, and so on. You can look at the details here. And this is what we're going to do. This is what we're going to use in today's video. So if you want to follow along, and if you also want to put your server onto the internet out there, you're going to need some VPS hosting plan. And I can recommend Hostinger for that. However, if you're not interested in building a Python application that you run on the internet, maybe you want to have a shared web hosting plan as well, because Hostinger also offers you these shared web hosting plans where you can use basic PHP and MySQL. You can build a WordPress website. I have a tutorial on this channel here where I explain to you how you can build your own first website. You can take a look at these prices here. They're fair prices, and you can also get some % off with my coupon code that you will find in the description down below, and I'm also going to show it somewhere here. So you can get cheaper prices here, and you can build your own first blog, your own first website, your own first portfolio of applications where you can showcase your projects. And for this, you can use the shared web hosting plans, and for today's video, you can use the VPS hosting plans of Hostinger. The process of setting up a VPS server on Hostinger is quite simple. You only need to choose a server name, a location, a root password, and an operating system that you want to use. For this tutorial, we're going to use Ubuntu. Once your VPS has been created successfully, you can proceed to the control panel. There you can find your server as well as see all the information that you need. For some reason, I had to set my root password again, so just scroll down and choose a root password with a minimum of 12 characters. Now, once we're done with the basic setup, we're going to connect to the server via SSH. So we're going to look at the SSH details here. The important thing is the IP address and the username. And we also need some SSH client. Now, you can use PuTTY if you want to, if that's how it's pronounced, or you can just use the Windows command line. So you can open up CMD and say SSH and then root at IP address. I'm going to use the Windows subsystem for Linux. So I'm just going to open this Windows terminal here. And same goes, by the way, for Linux and Mac as well. So you just say SSH and then root at the IP address that is written up here. And once we have that, it's going to ask for a password or for our password. Mine's a bit long. There you go. And once you're logged in, it's going to say welcome to Ubuntu in my case. And now we can go ahead and just say ls to look for the different directories. In my case, I have 2 directories here already. So I have my server, Python server. In your case, probably you're not going to find anything. So you can create a new directory by just saying mk directory here, make directory, and then we're going to choose a name, for example, app server. Like that, and then we can navigate to that directory, and in here you can just create new files. You can either use vim by saying vi, you can use nano if you want to, or you can just use sudo apt install and then whatever application you like to edit code in the command line. In my case, I have set up neovim with the whole config. I have a video on that on my channel, my neovim config. And basically you can just use nano. I think nano should be pre-installed as well. So let's just see server.py. This should be possible. There you go. You can also use nano if you're more comfortable with that. I'm going to use neovim, so server.py. And here we're going to start to develop the server first, and then we're going to develop the client. All right, so let's start with the server implementation. We're going to start by importing socket and by importing threading. Those are 2 core Python modules that we're going to need, so we're not going to have to install anything here. And we're going to first need the host and the port that the server is going to be running on. And for this, we're going to dynamically determine the IP address, and this is going to be done by socket.getHost by name, socket.getHostname, like that. And the port is just going to be something that is not really used by anything, so 9999, for example. And we can go ahead and create the server socket. So server equals socket.socket, socket.af_inet for internet socket, and socket.sock_stream for TCP. Then we're going to bind the server to the tuple of host and port, and then we're going to start listening for incoming connections. So what we're also going to need is an empty list of all the clients and an empty list of all the nicknames. And whenever a client connects, we're going to add nickname and client to these lists. So we're going to say clients equals empty list and nicknames equals empty list as well. And what we're going to do then is we're going to say, we're going to define the individual functions. So we're going to have one main function that is constantly listening and accepting incoming connections. Whenever an incoming connection is accepted, we're going to have a handle connection function that is going to handle that specific connection in a separate thread. And then we're going to have a broadcast function to communicate to all the connected clients. So let's start with the broadcast function. We're going to say def broadcast a certain message is going to be done by saying for client in clients client.send message, like that. And we're not going to encode that message because we're going to expect that this message is already encoded when we pass it to broadcast. So we're also not going to decode messages that we get from clients to be broadcasted. But that's a very simple function. Then we're going to have the handle connection function, handle connection. We're going to pass a client to this one. And basically the main function is going to get the client by the accept method. It's going to pass it to the handle connection function. And here we're just going to say stop equals false, and while not stop, is this right? Yes, while not stop, we're going to say try to get the message from the client. So message equals client.receive 1024 bytes, and if possible, if we get a message, we're going to broadcast that message here. If we get some exception here for some reason, we're just gonna say, okay, the index of the current client is going to be clients.index client. So it's going to give us the position of this particular client in the clients list, and then we're going to just say clients.remove this client from the list, and we're also going to say nicknames, or actually nickname equals nicknames at that position, index, and then nicknames.remove nickname, like that. This should work out. And then we're just going to broadcast a little f string that says nickname left the chat, like that. And we're going to encode this, of course, using UTF-8. There you go. So that's a basic handle connection function. The only thing that's missing here is we need to say, first of all, we need to close the brackets here, and then we need to say stop equals true so that the loop doesn't continue. Yeah, and now the only thing that we need in the server is the main function that is accepting the connection. So we have this main function that we're going to run, and we're going to basically just say print server is running so that we know that at least the script is working and running. And then we're going to say while true, we're going to accept incoming connections. So client and address is going to be server.accept. This returns two values, the client and the IP address. And then we're just going to say print connected to, and then address. And of course, we need to make this an F string, otherwise it won't work. And once we have that, we're going to ask for a nickname. So we want to send to the client something that requests a nickname. So we're just going to say client.send, not an F string. We're going to send the string nick with capital letters. We're going to encode this, of course, with UTF-8. There you go. And the idea is the following. The client is going to see that this is the nick keyword, and then it's going to know, okay, the server wants to know my nickname. It's going to send the information. We're going to store that in the nicknames list. And as you can see, we're communicating via the client object. We're not using the server socket. The server socket is only used for accepting incoming connections. And when we accept the connection, we get a new socket to communicate with that particular client. So once we have that, we're just going to say, okay, we send that request, and then we're going to get the nickname, which is going to be client.receive 1024 bytes. We're going to decode what we receive, UTF-8 here. There you go. And then we're going to say nicknames.append nickname, clients.append client, and then we're going to also print nickname is nickname. Of course, make this an F string as well. And then we're going to broadcast to all the connected clients that the nickname joined the chat. There you go. And now we need to just say client.send. You are now connected, or anything that you want to send. Don't forget to encode it. UTF-8. And there you go. I think here we also need to encode it because the broadcast, yes, of course we need to encode it. So encode this one here as well, UTF-8, because we need to send bytes. And last but not least, all we're going to do is we're going to just say a new thread is going to be thread with a target of handle connection. And the arguments is going to be client, like that. And we're going to start that thread. And then we're going to say if underscore underscore name underscore underscore equals main underscore underscore, then we're just going to call the main function. So that is the server. I'm not sure if I made any mistakes. We can just see if it's running or not. So let's just say python3 server.py. At least it's running. I'm not sure that it's going to be without any errors, but I'm going to try with the app that I already have if it works. And if it works, then we can continue with the actual app. So I'm going to connect to the server 3.1.170.1. 165.142, and we're going to connect with some nickname here, connect. Thread is not defined. Oh, there you go. We have a mistake. The problem is, of course, that thread is part of threading. So we need to say threading dot thread. But besides that, everything seems to work fine. So let's just close the app again because the app got an exception as well. I'm gonna run the server. Address already in use. Do I have some jobs running? Why is the address already in use? Okay, let me fix that mistake. We're going to go, I'm going to come back to you in a second. All right, so the mistake actually just fixed itself. We just had to wait for half a minute or something. So now let me run the server again. And if I connect now, as you can see, it works. Nickname is neural9. And if I send something, you're not going to see it on the computer, but I see that it works. So the server is the same as the complete server. So we're done with the server side. All we need to do now is we need to create the application, which is running on the desktop and on the mobile phone. All right, now let's start with the client implementation. And for this, we're going to use Kivy because we want to have it on Android. We want to have it on Windows. And if you want, you can even compile it for iOS. But I think for that, you need a Mac. So I don't have a Mac. I'm only going to show you how to do it for Android and desktop, Windows desktop. So what we're going to do first is we're going to install Kivy by opening up a command line, cmd for example, and saying pip install Kivy, like that. So I'm not going to run that because I already have it. You just run that, install Kivy. And then what we're going to do is we're going to put the design, the whole user interface, into a separate Kivy file. Now, I have a video on this channel on how to create an Android app in Python where I explain all the basics. And I'm not going to skip the basics here, but I'm not going to start slowly with the structure of a Kivy project. What you need to know is you have a Python file with all the functionality, with all the Kivy logic, you could say, and we're going to have a separate Kivy file with all the UI elements. So we're going to create a new file and we're going to call it Android, or let's call it neural web chat.kv. And this is going to be the design file. As you can see, we already have the Kivy logo here. So we're just going to design the UI using this Kivy file. And what we're going to have first is we're going to have this element that we're going to call, let's call it my root. And inside of my root, we're going to have a bunch of different elements. First of all, we're going to have a basic grid layout. Maybe I'm going to show you first in Paint how I plan to do this. I mean, we already saw the app in the preview, but what we want to have is we want to basically have the server IP here. We want to have the nickname here. We want to have a basic, oh no, make this black, please. Want to have a basic button that says connect down here, and we want to have some labels. So we want to have the label IP here, the label nickname here. We want to have connect here. We want to have these two text boxes here. And once we click on connect, those shall disappear. So those shall disappear. And then down here, we have the chat history with a label, of course, up here. And we want to have our own message box and a send button down here. So this is the graphical user interface. And because of that, what we're going to do is we're going to choose a vertical layout from top to bottom. But inside of that vertical layout, we're going to have a grid layout for these elements up here. So this is how I plan on doing it, or at least for these elements, whatever. I'm not the best designer. However, I want to also mention that the GUI is not the focus here. So you can make the user interface however you like. The important thing is that the boxes are there and that the buttons are there. You don't have to care about the design at all. You don't have to care about the colors, about the layouts, anything. You can also just stack everything on top of each other. I'm not going to care about the design too much. The focus is on the functionality. We want to have an Android app that can connect to the server and can send some messages. So this is what we're going to do. And for that, we're going to have a grid layout. And this grid layout is going to also have an ID because we're going to need that later on to make it disappear. We're going to have this grid layout, and the ID is just going to be connection grid because that's where the UI elements regarding the connection are going to be. We're going to have one row, or actually two rows. Let's go with one row and two columns. And we're going to have a padding of 10 and a spacing of 10 and a height of 125. So those are the basic properties of the grid, and we're also going to set the size hint to 1, which means that it's going to stretch horizontally, but we're going to set this to none when it comes to the height, so we can set the height here manually. Otherwise, it would just ignore our height here. And inside of that grid layout, what we want to have is we want to have 2 box layouts. And inside of those box layouts, we want to have the individual UI elements. So we're going to say box layout. And inside the first box layout, we want to have the orientation to be want it to be vertical. And we're going to say I want to have a label in here. This label is going to have the ID. Or actually, do we need the ID for that? If we're going to make this appear, we're going to make the whole grid layout disappear. So I'm not sure if we even need an ID for this label. So I'm just going to skip that for now. We're going to have the text, which is just going to say server IP. Then we're going to say font size of that label is going to be 42. And the color of the label is going to be something. I'm just going to pick some orange here. 0.92, 0.45, 0. Those are the RGB values normalized. And then we have the opacity, which is going to be 1. All right, so that's the label. Then we're going to also add a text input for the actual IP address. And here we're going to have the ID IP_text. And we're going to have the size hint again set to 1 and none so that we can manipulate the height of the box. We're going to set the height to 50. And we're going to set the font size to 36. There you go. Now, if you want to have these IDs, you also have to define them up here again. So what we need to do here is we need to say that if we're talking about IP text in the code, we mean IP text in a design file. So every time you use an ID, you want to specify it up here as a pair as well. So what we're going to do now is we're going to copy that because this is just the left side. We also want to have, we also want to have the right side. So come on, can I please just insert this normally? Okay, seems like I can't. So let's just indent this 2 times. There you go. And here we're going to say nickname. We're going to leave the rest the same. Just this is going to be nickname text. And of course, we need to also say nickname text here and nickname text here. There you go. So this is the basic grid layout. We have 1 row with 2 columns. First column is this box layout. Second column is this box layout. And below those, we want to have a button for the connection. So we're going to say below the grid layout, so you want to have it on this level of indentation here, we're going to have a button, and this button is going to have the ID connect btn, and it's going to have the text connect, and it's going to have the font size of 32. By the way, feel free to skip that part if you want to make your own layout, so you don't have to copy my layout. It's a pretty boring part of the project, so you don't need to follow along with this. This is just some basic UI stuff. We're going to set the size to 150. We're going to set the size hint to 1 and none again so that we can manipulate the height. I'm going to set the height to 70. And actually, is this redundant? I'm not sure. To be honest, I made this layout and I'm not even sure that it's optimal or that it is how you should be doing it. I'm really not a UI guy, so I'm just copying what I already did. So maybe height and size 50 is contradictory, but it works, so I'm going to leave it like that. You can play around with it if you want to. And we're going to add an onPress event later on. So we're going, or actually we can add it right now. So we can say onPress, we're going to call a certain function. This function has then to be defined in the code later on, but we're going to just call it root.connect to server, like that. So when we click that button, this function is going to be called. All right, so after that, we want to have a label again for the chat history. Then we want to have a text input for the chat history. We want to have another label and another text input for our message, and then a button for sending. So we're going to say label, and we're going to say text chat history. We're going to say font size equals 42. We're going to set height to 50. Going to set size hint to 1 none again. And what else do we need? The color, obviously. 0.92, 0.45, 0, and 1. There you go. Now a text input, a simple text input. Maybe I can even copy, or actually no, this is quite different. So I'm going to just write it myself again. So this is going to be the ID chat_text. We're going to also say size hint here is going to be 1 none, but this time we're going to go over the size, over the height. So we're going to say height is going to be 450. We're going to set this to multi-line true. And we're going to say font size equals 36. And we're going to make this read only, because obviously we don't want anyone to be able to write something directly into the chat history. So read only true, and disabled is also going to be true, because we don't want to write manually into the chat history. We want the program to write into the chat history. And now I can copy that and paste this down here. Change this to your message. And then I think I could copy that as well. And we're going to call this, what did I call this here? Message text. And the font size is going to be 36, but we don't need that, we don't need that, we don't need that, we don't need that, and that. And last but not least, we want to have a button. And this button is going to have the ID sent btn. And we're going to have the text sent. Gonna have the font size 32. Gonna have the size 150. Gonna have on press is going to be root.send_message, another function that we're going to implement. And we're going to disable it in the beginning, because we want to enable it once we connect. Now, don't forget to add all these IDs to the top. So 1, 2, 3, I think that's it, or connect button as well. Okay, so we're going to say connect button is going to be connect button. Then chat text is going to be chat text. Nickname text is going to be nickname text. Oh, actually, we do have nickname text already. What was the other one? Did I call it message text? Yeah. Message text is going to be message text. And finally, we had the send button, which is going to be the send button. So that is the whole UI. All right, so now we get into the interesting part, which is the Python scripting. Just keep in mind that if you want this to work, the Kiwi file has to be in the same directory as the script when we're going to create the class name, because otherwise it's not going to associate the class name with the Kiwi file. So we're going to start by importing Kiwi. We're going to start by importing from Kiwi dot, what was it, app, import app from Kiwi dot uix dot box layout. We're going to import box layout, and then we're also going to import socket, and we're going to import threading. There you go. We're going to require Kiwi version 1.9.0, because in my case 2.0 does work on my computer. It does not work on my smartphone. I'm using the Samsung Galaxy S7, so if you're using a similar phone, maybe you're going to have the same problem. But this version works fine, so you can look into the documentation if you need some special features of the latest version. But we're going to use 1.9, and we're also going to create a client socket right away. So client equals socket, socket.afinet for the internet socket, and socket.sockstream for TCP. And then we can start with the class definition. We're going to call this class myRoot, and it's going to extend from the box layout, and we're going to define it in a second. What does this mean? This means that myRoot is basically a box layout, and you need to keep in mind that this name here has to be the same as this name here. So myRoot here is going to be linked to myRoot here, which basically means that this here is a box layout. And inside of that box layout, we have a grid layout and we have buttons and labels and so on, which basically means that we're just going to stack these elements vertically again. So inside of that myRoot, we're going to have a basic constructor, self, and we're going to call the super constructor here. So we're going to pass myRoot and self and then call .init like that. And then we're just going to implement the basic functionality. So we want to have a send message function and we want to have a connect to server function. I want to have a receive function and all that. But the basic app is going to be running down below, and the app is called Neural Web Chat like that. And it's going to extend from app. And all we're going to do here is we're going to define the function or the method build. And this is just going to return myRoot like that. And then all we need to do is neural web chat equals neural web chat and then neural web chat dot run. So the idea is that this is a UI element with all the functionalities. This is the definition of the UI, and this down here is the app which returns the UI once it's being built. It's important that this name here, neural web chat, is the exact same name as the Kiwi file, and it's important that the Kiwi file is in lowercase. Doesn't matter what the class name is like, it has to be in lowercase, otherwise it's not going to work on your phone. All right, so in here we're going to now define all the functions that are important to us. Remember, we had this button being connected to connect to server and this button being connected to send message. So now we need to implement these functions. And let's start with the connection. So let's start with connect to server. Once the button is clicked, this function is going to trigger. And this function is basically just going to say if self dot, and now we can access, even though it's not going to show in PyCharm, we can access all of these elements here by using their names. So we want to know, okay, is the nickname provided? Was the nickname provided? And if not, we're not going to proceed with the connection. So we're going to say if self dot nickname underscore text is not equal to an empty string, then we can connect. Otherwise, we're not going to connect. So if this is the case, if we have a nickname, we're just going to send client.connect. We're going to connect to the text of the IP. So we're going to take the tuple of self.ip text, and I think the attribute is text.text, and the port is going to be 9999. There you go. So we're going to connect to that server on that port, and we're going to get the basic message from the server. So we're going to say client.receive 1024 bytes, and we're going to decode this. Actually, I'm not sure even that we need to do this, because the first message is just going to be, or actually we need to do this because we need to know that the first message is the nick message, because otherwise we don't have to send our nickname. So we're going to decode the message, and we're going to say, okay, if this message is asking for the nickname, so if the message content is nick, then we're going to say client.send self.nicknameText.text.encode UTF-8. So we're going to send the nickname to the server, and we're going to disable all the connection buttons, and we're going to enable all the other buttons. So we're going to say self.sendButton dot disabled is going to be false, and we're going to do the same thing with the message text. We're going to do the same thing with, or actually we're going to do the opposite thing with the connect button, because once we're connected, we don't want the connect button to be available anymore. So we're going to say this is true, and we're going to do the same thing with the IP text. Now set this to true. There you go. So this is the basic connection, and what we're also going to do is we're going to make the whole UI elements invisible. So the whole grid layout and the button are going to be invisible, and in order to do that, we're going to write a simple helper function. We're going to call this make invisible, and we're going to pass to that function the widget that we want to make invisible. So the widget, and all we want to do is want to say, okay, the widget is going to be set to invisible, but we don't do it with invisible equals true, but with visible equals false. And then we say widget dot size hint, size underscore hint underscore x equals 0, or actually, do we set it to none or 0? Set it to none. There you go. Y. Then we set the height, the width to 0, and the text to empty. So we say widget dot height equals 0, widget dot width equals 0, and widget dot text is empty if it has one, and then widget dot opacity equals 0. So we make this element disappear basically. And what we can do here is we can just say make invisible, and then self dot, what was the grid layout called? Connection grid. We didn't include it up here. Connection grid, like that. And we can now refer to it, connection underscore grid. We make this invisible, and we also make invisible self dot connect underscore btn. And of course, to access the function, we need to include self in the beginning. There you go. So this should work, and once this is done, we can start a thread for receiving. So we can say thread equals threading.thread, like that. The target is going to be self.receive, and we don't have that function yet, so we need to implement it, and we're just going to start this thread. And the receive function is going to be implemented down here. We're going to say receive self. And in this function, we're just going to wait for new messages. And once we get a message, we're going to add it to the chat history. So we're going to say stop equals false while not stop. We're going to ask for new messages. We're going to try to get new messages. So message equals client receive 1024 decode UTF -8. And then we're just going to say self.chat text.text is going to be plus equals message plus \n for a line break. There you go. What's the problem here? Accept or find. Oh, yeah, of course. We need to also have an accept here. And if there is some error, we're just going to print error. Doesn't really matter. And we're going to close the connection. And we're going to say stop equals true. There you go. So do we have something missing here? Yes, of course, the send message function is missing, but this is a one-liner. So send message, send underscore message. It's going to be quite simple. We're just going to say client dot send, and then self dot, actually maybe we should use an f string. We're going to say self dot nickname text dot text, and then colon self dot message text dot text, and we're gonna encode that using UTF -8. There you go. So I think that should be it. Did I forget something? I don't think so. Now, chances are it's not going to run first try, so let's see if it runs first try. I don't believe it, but maybe. We have a problem. Property name, invalid property name, size hint. Of course, because which line is this? There you go. Here we need to add a colon and a space. Do we have a problem besides that? Oh boy, what is that? We messed up the graphical user interface. Let me just compare real quick what we have different from the prepared code. Oh, I think we need to have the orientation vertical here as well. Does it work now? There you go. Doesn't look too bad. Yes, looks fine. So we have server IP, nickname, we have the text boxes we can connect, but I can already write a message. This is not what I wanted, so I have to set this to disabled by default. Do I set this to enabled again in the code? There you go. I do it anyway. So let's see. And let's maximize this. We're now going to run the script and see if it works. I just need to go to the server real quick and run the server. I got to say Python. Let me show you what I'm doing. Python 3 server.py. So the server is running. And now what was the IP address? This was the IP address. So I copy that. I go to the Python app. I paste it in here. And I choose a nickname, hello, and I connect. Does it work? Hello, joined the chat, connected to server. Hello, world. Sent. Okay, it seems to work. So now the only thing left is to get this and make this into an Android app. Now, in order to turn this application into an Android app, we're going to need a Linux system. Now, you don't need to have a full Linux desktop system. You can also use the Windows subsystem for Linux. You just need a Linux terminal. Then you go to builddozer.readthedocs.io and you can just follow the instructions here. So you can install pip. Using pip, you can install the builddozer. You can install all the packages that you need on your Linux system, and then you're ready to go. First of all, if you don't know how to install the Windows subsystem for Linux, I have a video on this channel. Also, if you're a little bit confused about this process, I also have a beginner Android app development tutorial with Python on this channel. Check out both of them if you are not able to follow along without help of those. All you need to do is you need to install builddozer on a Linux system, and you need to install these things to run builddozer. So once you have that, you can run your Linux system, and you have to navigate to the directory where your files are at. In my case, this is my Neural 9 development directory. I have a shortcut for it. And I'm going to navigate to my app, and here I have the Python file and the Kiwi file. All I need to do now is I need to say builddozer init, like that. Builddozer init. When I do that, you can see a file builddozer.spec was created, ready to customize. So I can now open this with any editor. You can use the Windows Notepad, you can use Vim, you can use Nano, whatever you want. I'm gonna use NeoVim, and in here, I can specify everything that is important for my application. First of all, I can choose a title, Neural Web Chat, for example. The package name can be Neural Web Chat. The package domain can be, I don't know, org.neural or something. Choose whatever you want. Then you can choose which files to include. What's important here is the permission. You need to have the internet permission. If you don't have the internet permission, you're not going to be able to communicate using sockets. So what you need to do is you need to look for permissions, and here you have Android permissions. Come on. Permissions, there you go. Android permissions equals internet. So I'm gonna uncomment that. This is what you need to do in order to be able to use sockets. And what you can also do is, let me just see where it is, the pre-splash file name. If you want to change a custom, if you want to have a custom pre-splash and a custom icon for your app, you can provide the file path here. You just need to make sure that you can include it when you do the compilation process. I'm not going to do this for this video. However, in my Android app development video, I have also shown you how to do this. So if you, for some reason, have difficulties with the icon and the pre-splash, you can watch that video as well, but it's not a complicated process. You just remove the comment here and you choose a file path to a PNG file, which you want to use as a loading screen and as an icon. So once you have all that, you can save it, and then you just type builddozer Android, or actually builddozer-v Android debug. And that's it. Now you have to wait for about 10 minutes, 20 minutes, I don't know, depending on your computer. This takes quite some time, but this is now compiling your program into an Android application. And I'm going to get back to you once this process is done. All right, so it took quite some time, but we're now done. You can see the build was successful in 26 seconds. So the whole process took like 40 minutes, but the build itself was done in 26 seconds. And if we now go to PyCharm, you can see that we have a bin directory, and inside of that bin directory, we have a .apk file. Now, the only thing that you need to do is you need to get that APK file onto your Android phone. You can do it with a cable, with a USB cable. You can upload it to Drive and download it. You can use an FTP server. It doesn't really matter. You want to get that file onto your phone, open it, install it, and then once this is done, you're going to be able to run the app. So I'm going to show you what this looks like here with the screen recording. You just click onto the app, you open it, it's loading, and then you have the graphical user interface that we just designed. We can also open it on Windows so that we have a chat partner. So we're going to load the project here as well. So we're now running it on Windows and on the phone. And we're going to start the server now. So I'm connected to the server. I'm going to run the server.py. Server is running, and now I'm going to connect. I just need to know the IP address. Where is it? I think it's somewhere up here. There you go. 31.170.165.142. And neural9 is going to be the nickname. Connect. There you go. You're now connected. You can see down here that the nickname is neural9, and I'm going to now copy this IP address here and also paste it in here and choose the nickname Florian. Connect. Now I joined the chat. You can also see in the phone I joined the chat, so I can now type hello and send a message, and on the computer I get hello, then what's up, ? Send. There you go. As you can see, this works on the desktop, on the phone, and it also works on the server side. So that's it for today's video. Hope you enjoyed and hope you learned something. If so, let me know by hitting the like button and leaving a comment in the comment section down below. Of course, don't forget to check out Hostinger and the coupon code in the description down below. And other than that, thank you much for watching. See you in the next video, and bye.